Good morning and welcome to this first annual conference on the future of vaccine development. I'm Ian Gust from the University of Melbourne and Chair of the Board of Directors of the Human Vaccines Project, which, with the Michelson Foundation for Medical Research and the University of Southern California, are your co-hosts today. If you look back on the last century, it's clear that the tools of classical microbiology and immunology have enabled us to develop an impressive array of vaccines which have had a profound impact on human health. It's also clear that those tools have got significant limitations. They've not enabled us to develop highly effective vaccines against major killers like TB and HIV and malaria, or to provide vaccines which are equally effective in the young and the elderly and in the developed and the developing world. But as you'll hear today, an amazing array of new tools have become available which should help us to unlock the secrets of the immune system and usher in a new era of vaccine design. Wayne will speak later on the Human Vaccine Project, and the conference is structured around several themes that are critical to its success, particularly decoding the human immunome, the potential of new technologies to provide a deep understanding of the immune system, and the potential to use that information, the information that's generated, to design new vaccines or improve existing ones. I'd now like to call on Steve Kay and Wayne Koff to make a few introductory remarks. Steve is the Director of the USC Michelson Centre for Convergent Biosciences and the Provost Professor of Neurology, Biomedical Engineering and Biological Sciences in the Keck School of Medicine, and he's promised not to talk about either the cricket or the World Cup.
Yes, let's not mention Belgium tomorrow. Thank you very much, Ian. Really, folks, today is all about celebrating great science, and in particular, celebrating the innovation and entrepreneurship of people who can do things that people my age can't anymore, and that is think creatively. I think that on behalf of all of USC, we're particularly excited to be chosen as the venue for the inaugural conference for the Michelson Prizes in Human Immunology and Vaccine Science, because this building that you're standing in is entirely due to the generosity of Gary Michelson. So back in something like 2014, Scott Fraser and myself met with Dr. Michelson and laid out a vision for how we wanted to take interdisciplinary research and really find ways to scale it. Ways in which you could reach out across disciplines in a much more aggressive way than had been done, say, juxtaposing a biochemist with a cardiovascular physician, and build a community that was full of data sciences, machine learning people. Right underneath where you're sitting is a massive industry-scale nanofab facility. We have imaging capabilities that span from material science all the way up to large-scale imaging. Scott will be talking about some of that in the last talk. And what we want to do in our Convergent Bioscience program is bring together scientists who really are heads up, who want to look away from only building just their own empires and reach out, stretch across fields where they can really do something new. And we see this as happening in both a bottom-up and a top-down way. In a top-down way, we as administrators incentivize some big science projects that we have going on in the building. These would be things like liquid biopsy for cancer detection, or a complete molecular level model of the beta cell, where we're looking at how multi-scale modeling from atomic level all the way up to physiology can be predictive in terms of determining better strategies for disease treatment. We have chemists, world-class chemists who are enabling, for example, people like in my lab who do small molecule drug discovery and allowing us as academic researchers to take those small molecules, for example, to pre-IND level rather than letting them go at a much earlier stage. So convergence really is about that transdisciplinary reach and a way in which we want to stretch across disciplines more than any of us as individual PIs normally can do. Dr. Michelson, who unfortunately right now is absent this morning, he's not someone who's easily micromanaged. I know that from working with him for the last 4 or 5 years. I should tell you that this is an extraordinary individual. Many of us in our home universities, of course, work with philanthropists, but Gary is someone who, first of all, is not at all shy at thrashing university administrators. He's someone who arrives at his own convictions about scientific fields and then decides to move forward on them. So not only would we not be in this building, it would be a dirt parking lot without his $50 million gift that he made to us, but neither would we be here today without the generosity that he showed when I was there when Wayne really first met him at Gary's house, where we got a tour of Gary's back garden. And I could see these two lighting up together. And it was really obvious to me that something special was going to happen once Wayne got Gary's ear. And Gary, who was very interested, of course, in how convergence ideas could be applied to this field. And Gary also was very keen to explore ways in which young scientists in particular could be recognized. So again, it's just fantastic to be here. It's fantastic to celebrate science and young scientists. And now I hand you over to our day's leader, Wayne Calif.
Well, thanks. I want to welcome everybody also. I've got a couple of slides I'm going to show, but I was just on a panel about a month ago, and somebody asked me, where are we going to be in 50 years in the areas of vaccine development? And the initial panelist on the panel, he was from industry, and he said, well, we have these great mRNA and DNA vaccines now, and it's going to revolutionize all of the vaccine field. And the next person on the panel said, well, we have these incredible adjuvants, and where is Natalie? She's here somewhere. And it's revolutionizing the field. And I said, we already have these. And what I did on the panel is I took out my cell phone, and I said, who would have thought a couple of decades ago we could almost do anything on our cell phone? And who would have thought if I turned over my cell phone, I can do an EKG? And so to try and think about where we're going to be is foolhardy. As a number of you know, I used to be in the HIV vaccine field, and about every other year I was asked, when are we going to have an AIDS vaccine? I didn't get that right either. So, not for lack of trying. So I just want to really introduce the vaccines project, and really the issue here is our lack of understanding of the human immune system. And you're going to hear a lot all day today on the huge advances that people are making in decoding the human immunome, and understanding of the initial understanding of the rules of the human immune system. But currently, we don't really understand our own system. We know a lot about ovalbumin in mice. We know the mice lie, and the monkeys don't always tell us the truth. And if we could really understand our system, it's going to open up the doors for a range of vaccines and the diagnostics and therapies against a range of the diseases. And you're going to hear about some of that here today. We have a talk on one of the cancer vaccines. We have another one on the atherosclerosis vaccine. And we have the one that we really need on the Alzheimer's vaccine. And as Steve's pointed out, it's all about the convergence and the recent of the convergence of a range of the technologies shown in this slide here. We couldn't have thought of the idea and implemented the idea of the Human Vaccines Project even a few years ago, but the advances that we've seen in terms of the immune monitoring and imaging and AI and machine learning have really given us the opportunity for the initial time in our field to really do a decoding, if you will, of the human immune system. So where is the future of vaccine development? Well, we had our advisory board in the other day, and we had a number of excellent talks. And Rina Rapuli, he showed a slide that I borrowed here, where can we move from what we've done in the past, where we have these enormous efficacy trials that have 100,000 people or 10,000 people, and we only look at a couple of the data markers, the antibody titers as an example, to a smaller trial of either 10 or 100 people, and to have a range of markers, to have thousands of the markers. We see that as the future of vaccine development. And our vision here is to really harness the power of the human immune system and revolutionize the overall field of vaccine development. So we have vaccines that are made faster and cheaper and increase our probability of success. And we revolutionize the vaccines so we have a single dose and lifelong of the protection in everyone. So we've talked a lot about the tools. We're also here to talk about the Michelson Prize and the awardees. So just to wrap up the introduction, we've seen over the years how the Genome Project, which has given us a single genome initially, and now we do genomes in everybody's lab at $1,000 a day. Well, if we could understand our human immune system, we have the potential here of opening up a whole new era of the public health. So as Steve's pointed out, we wouldn't really be here in this building and in a discussion of the young talent if it weren't for the incredible of the philanthropy and the vision of our friend who just walked in the corner, who I'd like to have him stand up and give a round of applause. It's Gary Michelson. And so as Steve pointed out earlier, that we had met Gary about a year ago and went over and took a lovely tour of these incredible gardens that he has at his house. And we were talking about ideas outside the box and really how do we engage the best and the brightest of the next generation of scientists into the areas of human immunology and vaccine research. And Gary said to me, I want to do a prize. And I said, well, I've never done a prize. But we'll figure out how to do this. And we set up this incredible team. And Stacy Wooden is in the back. And I'd like to ask her to rise also, because she put together this incredible team who over the course of a matter of weeks put the whole package all together. We got over 100 incredibly interesting applications from all over the world. We triaged them down to about a dozen. And we ended up with these 3 incredible proposals and 3 incredible people. And I'd like to ask each of them to rise. And so we can just give a round of applause to the Michelson winners, who you're going to hear from later today. So with that, I'll turn it back over to Ian, or I will turn it over to Gary for a few words. Ian had this laudatory introduction of you, Gary, and I know you don't like laudatory introductions, but
Thank you, sir.
great.
So, good morning, and really all I have to say is I'd like to thank USC for having hosted this first year's competition. To put a face on that, that would have been Max and Steve and Michael Quick. So we really appreciated that. The next thank yous go to Wayne, who did the impossible. I mean, he put this together so quick. If it wasn't for Wayne, we wouldn't be here. And then finally, I need to thank the Scientific Advisory Board of the Human Vaccines Project, who so selflessly gave their time and managed to award 3 prizes for 2 positions. And lastly, thank you all for coming today. Thank you.